Every crew gets to design their own patch. In this next scene here, you'll see our patch, which has the entire globe as well as the sun on it, symbolizing the global nature of looking at atmospheric research and the effect the sun has on the chemistry of our atmosphere. We had the opportunity to launch midday on November 3rd, which made it a very comfortable wake-up for half of our crew, waking up at 7 o'clock in the morning. However, because we were a dual-shift flight and conducted operations around the clock, the other 3 members of the crew had sleep-shifted themselves to wake up at 10 o'clock the previous evening. So they'd been awake about 12 hours, or actually 14 hours before we launched. We check the integrity of our suits, and then we walk out of the ONC building at the Cape to get on the Astrovan for the 7-mile drive out to the pad.
We had a beautiful morning for the launch. The skies were crystal clear, not a cloud in sight. At T-minus 6 seconds, the shuttle main engine start sequence began, and moments later we're on our way. The 66th mission of the Space Shuttle program and the 13th mission of Space Shuttle Atlantis. We were already over 100 miles an hour as we cleared the tower, and we began our roll maneuver to the attitude required for our 57-degree high inclination orbit. Our trajectory actually took us up the eastern seaboard of the United States, just off the coast. At this time, the orbiter, at liftoff, the orbiter weighed around 4 million pounds, and our thrust was around 7 million pounds, so the thrust to weight was pretty nice, and we were getting out of town in quite a hurry, as you can see. The orbiter was burning about 3,000 pounds of fuel per second, and as that weight decreased, the acceleration increased up to about 3 Gs, or 3 times the Earth's gravity. At 2 minutes into the flight, we had expended all the energy out of the solid rocket boosters, so they were jettisoned to be picked up by the recovery ships waiting about 50 miles off the Kennedy coast. It's hard to imagine we sit on the pad, and then just a few moments later we were at orbital speed just under 18,000 miles an hour, and we did all that in 8 minutes and 42 seconds. So you can imagine the ride and the acceleration was quite unbelievable.
At main engine cutoff, we went from 3 Gs to almost 0 G instantaneously. It was quite a spectacular sensation. My first job was to film the external tank, which was flying in close formation with us for post-flight analysis before it re-entered the Earth's atmosphere.
And one of the first things we do when we get to orbit is open the payload bay doors, and we do that for thermal reasons, but it's also a pretty exciting event for the crew because it gives us our first real view of the Earth from space.
The first day was very busy with activation of all the payloads, including the Krista Spa. You see Kurt and Joe in the forward flight deck controlling the digital autopilot and also keeping the big picture of on all the systems. While on the aft flight deck, Ellen is flying the robot arm to grapple the Krista Spa with a special electrical connector to activate the batteries. You see the arm closing to the payload. You can see the target, which is a very important visual cue for the arm operator to center the end effector and the snares around the grapple fixture. Then comes time for the deploy, and starting with the unberth of the payload very smoothly to prevent any saturation of the gyros on board the Krista Spa, and then maneuver from the low hover to the release attitude. You can see the mass antenna moving, scanning the atmosphere. This is quite a long maneuver from the low hover to release attitude. Krista Spa is a composition of the platform SPA and the instrument Krista and Marcy. Krista stands for Cryogenic Infrared Spectrometers and Telescope for the Atmosphere. And with the 3 telescopes on board and very high-speed sensors, it collects a very high space resolution data of the middle atmosphere. And when we get ready on the orbiter side as well as on Krista for release, I check the trigger to open the snares in order to start the release. And you can see now the end effector backing away from the payload. Very nice view of the Earth on the background. And when the arm stops at a few feet from the payload, Don from the aft flight deck will fire the first separation maneuver. And once the deploy is complete, the ground team and the crew on board is very happy with the successful deploy.
Here's a view of the payload bay showing the atmospheric and solar science instruments. The main structure that you see is the Space Lab pallet with the 6 Atlas instruments on board, as well as a lot of the support equipment. This is a close-up of some of the solar instruments, and you see the door opening on SolCon, which measures the amount of energy coming from the sun. And this is another view of the payload bay taken from the camera that's on the elbow joint of the robotic arm. Here's a view of SSBUV, an ozone measuring instrument, as the door opens and it begins to measure the backscattered ultraviolet light from the Earth, which will allow it to measure ozone.
This is the ESCAPE payload, a solar physics experiment sponsored by the University of Colorado, and it took advantage of 4 solar viewing periods throughout the flight.
This is the assembly of one of the biggest secondary payload in the mid-deck heat pipe performance experiment, dedicated to testing heat pipes extensively used on both automatic satellites to cool electronics. Helen is currently running a spin test where pipes are spinning to see how centrifugal force prevents the heat pipe to work properly, and we could set the power as well as the spin rate. We had also a PGAC to help collecting data.
This is the protein crystal growth experiment. We had 2 on board, and we've been told that we had the highest yield of some of the highest quality protein crystals they've ever seen since protein crystal growth experiments have flown on Shuttle. And the crystals will ultimately be used to determine their 3-dimensional structure and ultimately lead to better pharmaceutical development. And this is a close-up of one of the chambers showing some beautiful, very large protein crystals.
3 gold boxes that you'll see in the frame here on the locker doors were the accelerometers for the Shuttle Acceleration Monitoring System, SAMS, and we used that equipment to document the microgravity environment on the orbiter.
This is a piece of equipment called Albert that Jean-Francois and I used to position ourselves when we were operating the robotic arm for the deploy and the retrieve.
Our galley was the focal point of life on orbit. We hydrate some of our food with hot or cold water as indicated on the package. Then we cut the package open and eat the food with a spoon. Even after all those years of being told not to play with your food, when eating in space, it's almost too much fun to resist. Jean-Francois invented a new dish, shrimp cocktail on a tortilla. I think building the shrimp fajita was half the fun. Of course, eating it was pretty good, too.
We had plenty of cameras on board to document not only our in-cabin activities, but also the extensive Earth obs potential we had on our 57-degree inclination flight. We took over 6,000 frames of film on our 11-day mission, and it's a great opportunity to see the world without boundaries, and also to get a better feel for meteorology, oceanography, and geology. And this is a tremendous view of plate tectonics in action. This is the Indian plate meeting Asia, arising in the Himalaya range. And in the foreground, you can see the Ganges River here, several of its tributaries and alluvial fans that feed into the Ganges, and the foothills to the Himalaya range. And this is literally the roof of the world. There are several 8,000-meter peaks in this field of view here, including Mount Everest and Annapurna. Just a gorgeous sight that the Blue Shift had a chance to see on several passes. Up at the top of the field here is Bow Tie Lake, one of the landmarks that we use to identify Mount Everest as we go by. And now in the field is the Tibetan highland. It's a very arid land with a mean altitude of 14,000 feet above sea level.
This is a beautiful scene of the Great Barrier Reef off the northeast coast of Australia. You can see the coral formations, the different color of water indicating different depths, several plankton blooms, and the ocean currents in the sun glint to the right.
We had the opportunity to see several major storms while we were on orbit. This one was Hurricane Florence that occurred early in our flight. We had the opportunity to pass by and zoom in on the eye of the hurricane, and you can see a very well-defined wall.
We had the opportunity to exercise almost every day on orbit, and here you can see Jean-Francois enjoying the exercise, the music, and the view. It was pretty spectacular to do that. This is a view of the inner limb resistance device, an exercise device that I developed when I was out at Ames with one of my colleagues there. And it allows us to exercise all of our anti-gravity muscles while we're in space with minimal impact to the orbiter. In addition, it allows us to preserve some of our neuromuscular coordination when we return back home We can also reconfigure for upper body exercises.
During our half day off, we had a chance to play with zero gravity. And perhaps my drill instructor from officer school would be impressed with this maneuver.
Another big challenge during our little free time on orbit was with Scott and I trying to rendezvous two big bubbles of water together, and we managed to do that, although it's very difficult to handle this soft big bubble in the middeck. And even when you want to take a CD, you know, it flies away like a frisbee.
This is me being attacked by the morning mail messages from Mission Control one day.
We are frequently asked how we sleep in space, and though on different shifts, here the three rookies are demonstrating the use of our sleep stations.
We had a peculiar phenomena occur during one of our supply water dumps. We dump water overboard that's either not needed for cooling or consumption by the crew. You can see in the upper left corner here is the supply water dump nozzle with a stream of water coming out. What's building here is an icicle that formed on the outside of the cargo bay door, which is off the picture to the right. And the icicle formed and would have continued formation probably right up to the dump nozzle had we not stopped the dump at about this time. Now watch the plug here. This is a look at the entire icicle after it had formed about 6 feet long off the payload bay door, and that part of that ice remained all the way through the entry until post-landing. It was still on the vehicle.
Here we have the flight deck crew, Don, myself, and Joe preparing to do a procedure called flight control checkout, where we crank up one of the auxiliary power units for hydraulics, and we move all the flight controls and check all the instrumentation and displays out for our trip home, make sure Atlantis is ready to come home. Standard procedure we do every mission.
And after 8 days of free flight, it was time to join back up with Spots to bring it home. It is a beautiful sight here against the deep black of space. Kurt monitored the rendezvous and performed the final burns from the left seat, while I managed the various sensors used to display our approach on a portable computer. Don flew the final stages from the aft station, taking inputs from us and the computer program, but ultimately using the best sensors we had on board, his very own eyes. We worked our way in until we could see every detail of the surface of the Crystal Spas. Finally, for the grapple, Jean-Francois operated the handheld laser and gave Don and Kurt very accurate range and range rate measurements that allowed us to make our rendezvous time almost down to the second.
Here's a little closer view of Christus Spas as Don is flying the final part of the approach, and I'm getting ready to use the robotic arm to do the capture. And this is a view of the arm as it's coming in over the grapple pin, and then I initiate the capture sequence, which pulls the payload onto the arm and rigidizes it. Here's a view after we've captured it and before we've berthed it in the payload bay, looking out the overhead windows. And the rendezvous was accomplished on Flight Day 10. On Flight Day 11, we went into our final solar viewing attitude, the last opportunity for the solar instruments to take measurements. And then Flight Day 12 was our day to come home. And this is us preparing to come home, and one of the last things we do is close the payload bay door.
Once we have the payload bay doors closed, it's time to reconfigure Atlantis for the trip home. We get back in our orange pumpkin suits and we prepare for the burn. We use our engines to slow the orbiter back down to re-enter the atmosphere. It's time to turn some of that kinetic energy we gained during launch back into heat. And Joe's pointing out the window, so Jean-Francois takes a look, and you can see the plasma behind us as we stream through the atmosphere, converting that energy back into heat. Out my right window here, you can see the glow around the orbiter also as we're penetrating the atmosphere. Don's managing the energy, make sure we have good energy state, and here's a long-range camera from Edwards picking up our yaw jet thrusters still firing to maintain attitude.
This is a look out Kurt's right window there as we make about a 90-degree turn to final at Edwards. As we roll out on final, we had one final test to perform before we landed. It was a subsonic aero test to roll the vehicle left and right, and to yaw the vehicle left and right to look at control power and those control surfaces to see if there's a potential for more crosswind capability in the vehicle. Once that was complete, we rolled ourselves back out on final approach, We fly the approach now at about 300 knots equivalent airspeed. At 2,000 feet or so, we begin to decrease our glide angle from 20 degrees to just over 1 degree. At 300 feet, Kurt extended the gear for us, and as we continually decelerate, we cross the threshold of the runway at about 225 knots, 17 feet in the air, and targeting a touchdown speed of 195 knots. We touched down about 3,200 feet down the runway, and immediately after touchdown, we deploy a drag chute. We had the first reusable drag chute of the Space Shuttle program. The drag chute helps us decelerate as well as lowers the slap-down rates on the nose gear. The deceleration we get out of the drag chute reduces the amount of runway we use by about 1,500 to 2,000 feet. At about 60 knots, we release the drag chute so we don't have to contend with that hardware post-wheel stop. And by this time, we had flown about 175 revolutions of the Earth, and we'd been in space almost 11 days and flown 4.5 million miles. And we badly needed a shower and a home-cooked meal.